All right, we're looking at answers for AP test. Excuse me, AP test review number 3. Number 1 says we can use a calculator. It says a particle moves along the x-axis so that its velocity at time t between 0 and 5 is given by v. Particle's position at 8, or particle's position is 8 at time t equals 0. First thing we want to do is find the acceleration of the particle. So acceleration is the derivative of velocity. So since I'm using a calculator, I'm going to plug this in as a graph. Once it's plugged in as a graph, then I'm going to add a calculator page. On the calculator page, I'm going to do shift minus, which gives me the d over dx. Then I'm going to press the variable button and put F1 in there. And then outside of the parentheses, I'm going to draw that vertical line. Or not draw it. I'm going to get the vertical line, which is control equals. You can get it there. And then I'm going to put x equals 4. When I do that, it gives me 0.714, which is the same thing as 5/7. B. Find all times t in the open interval between 0 and 5, which the particle changes directions. During which time interval between 0 and 5 does the particle travel to the left? So to get where the particle changes directions, I need to look at velocity. So I'm going to go back to the velocity graph. Okay, I'm going to look at that, and I'm going to find my zeros between 0 and 5, and it's got to change signs. It's got to go from positive to negative or negative to positive. I'm going to do menu 6, 1 to get my zeros, and as you see, my zeros are 1 and 2. So I'm going to say that's the first part of the problem. I'm going to say 1 and 2 because velocity changes signs. And then when does the particle travel to the left? I need velocity to be negative. So from my answer between 1 and 2, my graph velocity must be negative. So that means we're traveling to the left. Particle's position at time t equals 2. So I am starting at 8. And then I'm going to add the integral. We're going from 0 to 2, so 0 to 2, and then natural log. I punch that in my calculator, gives me 8.368. Find the average speed of the particle over the interval from 0 to 2. Again, when you see that word average, I've got that 1 over b minus a out front. And remember, we talked about several times that speed is the absolute value of velocity. There's my velocity. So I want to integrate the absolute value of velocity. Remember, to get the absolute value, that button is next to the 9, to the right of the 9 button on the calculator. I punch that in, that gives me 0.370. So that's my average speed between 0 and 2. Next one is just an implicit differentiation problem. So derivative of x squared is 2x. Then on derivative of xy, I've got to do first derivative of the second plus the second derivative of the first. And then the derivative of y cubed gives me 3y squared y prime. I set that equal to 0, and I leave these two on the left and factor out the y prime. The 2x and the y need to go to the other side, so I subtract them, and then I divide. That gives me the answer of A. On 3, to work this out, we want to factor x squared minus 1. That's x minus 1, x plus 1 over x plus 1. X plus 1's cancel, gives me x minus 1. I integrate both of those. I plug in 2 and 1. We end up with 1/2 as our answer. We talked about number 4 extensively in class. Remember, all this is saying right here is that the function f, as x approaches a, has a limit of L. Okay, that's all it's saying, which is not much. So the derivative does not exist. We do not know that it's continuous. We do not know that f is defined at a, and we do not know that the function value equals the limit, which is what this is saying. Therefore, none of the above. Number 5 is a second fundamental theorem of calculus problem. I'm taking the derivative of an integral, which means I need to plug in my variable. I plug in my variable, and don't forget to multiply by the derivative of what you're plugging in. In this case, it's 1, so it's you don't see anything. So if I plug x in, I get the square root of 1 plus x squared. Easy problem. Okay, there's that word average again. So I'm going to do 1 over b minus a and then integrate, which is what I did here. I did a u for x plus 3. The derivative of that is 3x squared dx. I've got the x squared, so that means I got to move the 3 over, which means I got to have a 1/3. So that's why the 1/3 is here. Don't forget to change your limits if we have limits. So I plug 0 in here. 0 plus 1 gives me 1. I plug in 2. 2 cubed is 8. 8 plus 1 gives me 9. I integrate. Integrate the square root of u. That's going to give me u to the 3/2 times 2/3. I went ahead and multiplied the 1/2 and the 1/3 together to get 1/6. So 1/6 times 2/3 gives me the 1/9. And then all I have to do is plug in the 9 and plug in the 1, which is what I did here. This is asking for the square root of 9 and then cube it. So the square root of 9 is 3. 3 cubed gives me 27. 27 minus 1 gives me 26. And that's why we like 26 over 9. 7, just product rule. So first derivative of the second plus the second derivative of the first. Remember, anytime you're doing product rule or quotient rule and e to the x is involved, you always want to factor that out. So I factored e to the x out. I could also factor an x out, so that gives me x e to the x times x plus 2, which gives me the answer of C. Number 8. All right, so we have, excuse me, g of x is defined as the integral from 0 to x of f of t. We want to find g of negative 1. So I just plug negative 1 in here. So that means I just want the area between 0 and negative 1. So the area between 0 and negative 1. Since I'm going backwards, that means my sign is going to change. So this triangle is 1 by 3. So that means the area of this is 3/2. Since I'm going backwards, going from 0 to negative 1, that means it's going to be negative. G prime. All right, g prime of negative 1. I didn't show it, but I need to identify that g prime of x equals f of x. I should have shown that in here. So g prime of negative 1 equals f of negative 1. F of negative 1 is right here, and that value is 0. And then g double prime of negative 1 is the same thing as f prime of negative 1. I'm looking at f. If I'm interested in f prime, then that means I need the slope at that point. So the slope at negative 1 is the slope of this whole line. And if you notice, I'm going up 3 and over 1. So that means my slope is 3, which means g double prime of negative 1 is 3. Part B, we want to know when g is increasing. So g is going to be increasing when f is positive. We look at the graph, we notice f is positive between negative 1 and 1. So negative 1 to 1 because f is positive. C, when is g concave down? So g is going to be concave down when f is decreasing. And f is decreasing right here. And that is 0 to 2. So 0 to 2 because f is decreasing. And then we want to sketch the graph. So that means I need to get y values. I've already got g of negative 1. I can get g of 0 because if I plug 0 in there, I'm going to get 0. The other values I can get are the endpoints and then the other critical point. So the endpoints and critical points are what we want here. So negative 2, 0, and 1. So remember, we're starting from 0. So if I go from 0 to negative 2, notice that both of these are the same. So that means they're going to cancel out, and g of negative 2 is also going to be 0. And notice when I go from 1 to 2, all the way to 2, both of these areas are going to cancel. So that means g of 2 is also 0. And then the only one I need is 1. So 1 is this triangle right here, which is a 1 by 3. So 1 times 3 and half of that gives me 3/2. So that's where we get g of 1 is 3/2. We plug all of those, or plot all those values in there. And then to figure out the curvature, to figure out the concavity, remember we want to look at the original and figure out whether or not, we want to look at f, which is the derivative of g, and figure out when I'm increasing or decreasing. That tells me concavity. So if you notice, we're increasing from negative 2 to 0. So that means we're concave up. So that's why this section is concave up. And then we decrease from 0 to 2. So that's why this section is concave down. Number 9, I need the quotient rule. So bottom derivative of the top minus the top derivative of the bottom over the bottom squared. X times 1 over x gives me 1. This is natural log of x over x squared. My answer is D. Pretty straightforward. Number 10, we want to do a u for the denominator. So u is 3x squared plus 5. Du is going to be 6x dx. I've got the x, so that means I've got to have a 1/6 out front. So 1/6, the integral of u to the negative 1/2 du. I took the radical from the bottom and moved it up, so that's why this is negative. So if I add 1, I get u to the 1/2, multiplied by the reciprocal, gives me a 2. So 1/6 times 2 is 1/3. The only one of these with 1/3 in front of it is D, so my answer is D. 11. So this is one where this is the definition of the derivative, limit of the difference quotient. So we take the parentheses out and put x in its place, and that gives me my function. So that's where we get tangent of 3x. We take the derivative of that. So the derivative of tangent is secant squared. Inside stays the same. Derivative of the inside gives me 3. And that's why our answer is B. On 12, again, there's that average value. There's that word average. So that's 1 over b minus a times the integral of 3x minus x squared. So I integrate 3x. I get 3 over 2x squared. I integrate x squared. That gives me x cubed. We're going from 3 to 0, or from 0 to 3. Plug in 3 first. So 3 squared is 9 times 3 is 27. And 3 cubed is 27 times 1/3 gives me 9. I plug in 0 to both of these. That gives me 0. So 2 times 9 gives me 18. 27 minus 18 is 9. And the 9 and the 3 reduce. It gives me 3/2. So my average value is 3/2. All right. So we have 1 to 10 of f of x dx equals 4. We have 10 to 3 of f of x dx equals 7. And we have 1 to 3 of f of x dx is what we're looking for. So 1 to 10 is going to be equal to 1 to 3 plus 3 to 10. Well, instead of 3 to 10, we have 10 to 3. Okay. And I moved that over. And because this is backwards, I went ahead and switched it, which changed the negative to a positive. And then I can plug in negative, or I can plug in 7 here. And then 4 plus 7 gives me 11. If I had this to do again, I'd probably just, at this point, I'd probably plug 4 in here, get 4. And right here, I'd plug in negative 7, just because it's backwards. And then add the 7 over. 4 plus 7 gives me 11. I think that's the way I did it in class. Either way. 14, sides of a rectangle increase in such a way that dz dt equals 1, dx dt equals 3 times dy dt. That's the instant that x equals 4, y equals 3. What is the value of dx dt? All right, so I have a right triangle here, so that's going to be x squared plus y squared equals z squared, Pythagorean theorem. I take the derivative, I get 2x times dx dt plus 2y dy dt equals 2z dz dt. And I'm going to plug in 4. I'm going to plug in 3. 4 for x, 3 for y. So I plug in 4 here. 4 times 2 gives me 8. Then I change dx dt. It says dx dt is equal to 3 dy dt. So I took dx dt out and put 3 dy dt in right there. 2 times y is 3, so that's 6 dy dt. And 2 times z, I don't have z. Again, if I need something, I go back to the original. So I plugged in 4, I plugged in 3. Z squared equals 25, so that means z equals 5. So that means this side is 10. So 24 and 6, I put those together, gives me 30. I divide by 10, that gives me dy dt equals 10. So dy dt equals 1/3. Problem is, it wants to know what dx dt is. Well, we know that dx dt is equal to 3 times dy dt. So 3 times dy dt, which I just found out is 1/3. 3 times 1/3 gives me 1. And that is the answers for AP Test Review number 3.